MiTE stands for Microbolometer Thermoelastic Evaluation. It's a stress imaging technology that was developed at DST and is basically a compact, low-cost stress visualisation technology that in essence allows you to image the stresses that a load-bearing component is witnessing.
Everybody in the industry, everybody in the market just accepted that this wasn't possible. You can't see stress with such a low quality system. It doesn't matter what amount of software processing you do, you just can't see it. And that was just the adopted, norm within the industry. Whereas DST simply said, well, why not? All right, let's give it a go, let's give it a crack. And so they put some investment in, they put some time in, and they were determined, and they make it work, which is something I really like about DST. You see that happen in so many of the other groups within DST, is that with limited resources, they're able to make things work.
MiTE was used in the structural certification testing of F-35, which has led to improved lifing models for that aircraft, so we have a better understanding of how that aircraft will perform over its operational life within the Air Force. In the future it will be used more broadly, so we anticipate that this technology will in future be used as a structural monitoring modality, providing information on how an airframe is coping with the operational loads that are being applied to it.
The good thing is DST have done all the hard work. All right, so they've tested it. They use MiTE in the lab right now to do stress intensity testing when they do full-scale fatigue tests on aircraft. So we're taking what is a very robust software package, and we're looking to package it into a robust product. Right, which entails not just the software, but the camera, all the calibrations that need to be done beforehand, all the connections, all integrated into something that's quite simple, so that a user doesn't have to worry about being the scientist, they just have to be the user.
The capability basically is applicable to all new aircraft designs, so essentially the work that we did with F-35 we see as a blueprint for the application of this technology right across the aircraft industry, including both civilian and military.